आज का हमारा टॉपिक है बैटरीज. ओके, सो बैटरीज जो है, what are they? They are whatever batteries we are going to discuss over here. They all are a form of electrochemical or galvanic cell. They all are going to be galvanic cells in which chemical energy that is going to be converted into electrical energy, right? So there are two kinds of batteries which we are going to discuss. The first one are known as primary batteries. The primary batteries are non-rechargeable batteries. Non-rechargeable batteries which when once are non-operational cannot be recharged to make them operational. Okay, so once either the electrolyte or you can say the electrode or you can say either of the anode or cathode that is exhausted in such kind of batteries, it cannot be recharged, right? So we are going to do two kind of batteries over here, primary batteries or primary cells. The first one that is known as the dry cell or Lagrange cell. Okay, so we look at these cells. These are the cells which are generally found in torches. The normal cell which we can see. So if we see this cell, it consists of a carbon rod which behaves as a cathode, surrounded by a paste of manganese dioxide and carbon. Both of these, they are placed in a cylinder which is made of zinc. Okay, so over here we are saying that this zinc, it is going to behave as anode, and over here there is a seal at the top. Okay, and this is the anode, this is the cathode which is made up of graphite. Over here is the paste of manganese dioxide and carbon. Right, and this is placed in the electrolyte over here, which is a paste of NH4OH, sodium hydroxide. NH4OH. Now, when we are talking of this, we say ammonium, sorry, not NH4OH, it is ammonium chloride and manganese dioxide. So manganese dioxide over here we have taken, this is ammonium chloride, a paste of ammonium chloride. Okay, now when we are talking of the reactions over here, let's look at the anode reactions. At anode is formed of zinc, therefore zinc, it loses 2 electrons to undergo oxidation and converts into Zn2 positive. At the cathode, the ammonium ions reduce. So we have ammonium ions which are going to gain 2 electrons to give us ammonia plus H2. So if you look at the overall reaction reaction over here. Overall reaction, we add both the cathode and the anode reaction. The electrons, they can be cancelled. So overall reaction is Zn plus 2NH4 positive to give us 2NH3 plus Zn2 positive plus H2. This is going to be the overall reaction. Now the ammonia which is formed over, the hydrogen which is formed over here, that reacts with manganese dioxide to give us manganese oxyhydroxide. Manganese oxyhydroxide, and the Zn2 positive ions which are formed in the overall reaction. The Zn2 positive ions which are formed in the overall reaction that reacts with ammonia to give a coordinate complex tetraamine zinc ion. Okay, now in this case you can see over here that when we are looking at the overall reaction, the zinc is being corroded into Zn2 positive ions, right? And similarly NH4 positive ion from the electrolyte, they are being converted into NH3. So slowly and gradually what is going to happen is that zinc will keep on corroding, and as a result of this, the electrolyte which is left over here, that might ooze out of the cell. Okay? Or in other words, we can say that zinc is getting consumed. Okay? In a similar manner, NH4 positive from the electrolyte is also getting consumed. So you must have seen when you place the cells for a long time, there is a certain brown color mass which starts oozing out from the cell. Right? And that renders the cell dead. The EMF of this cell, that is approximately 1.6 volt. So once the cell is dead, either by the consumption of zinc or by the consumption of the electrolyte over here, we cannot recharge this cell again. Clear? So this is the dry cell or the Leclanche cell. The second type of primary cell is the button cell. The second primary cell which we are going to do, that is the button cell. Button cell is a flat kind of a cell which appears to us like a button. So thereby we call it as a button cell. This kind of cell, it is generally used in watches and also in toys, electronic toys like video games, pocket video games. So these cells, they are used over here. These button cells, they have very small size. Therefore, they can be easily portable. And also another example which we can take over here is that of hearing aids. Okay, they are also found in hearing aids. Now in this cell, the cathode, that is made up of mercuric oxide plus a paste of carbon. This is the cathode. The anode is again made up of zinc. Anode is made up of zinc, and then the electrolyte is a paste of zinc oxide and potassium hydroxide. So let's go on to the reactions. Reactions at anode. Anode is made up of zinc that reacts with the OH negative ions of the electrolytes. Okay? and because oxidation is going to take place at the anode, so minus 2 electrons to give us zinc oxide plus water. Then at the cathode that is made up of mercuric oxide is made up of mercuric oxide. Now this cathode, the mercuric oxide of the cathode that reacts with the water which is produced at the anode, and cathode wave reduction is going to take place, right? So this is going to give us Hg plus 2 OH negative. Right, so this is the reaction of the cathode. Now when we are looking at the overall reaction of this, then what you can see over here is that this electron gets cancelled with this electron, and OH negative at this side, they will get cancelled with the OH negative over here. So the overall reaction, that is going to be zinc plus HgO plus water to give us ZnO plus H2O plus Hg. This cell, it has more life than the Leclanché cell because of the fact that you can see in the final reaction, okay, water also gets cancelled over here. So if you're looking at the final reaction, we have Zn plus HgO to give us ZnO plus Hg. Okay. Now in this case, there are no ions involved in the overall reaction. As a result of this, it is going to have a greater life. The voltage over here is .35 volt. Okay. So this is the button cell. Then we go on to the next one, which is the secondary batteries. Secondary batteries, they are rechargeable cells. That is, once the cell becomes operational, it can be recharged by reversing the reactions of the cell. Okay, so while recharging the cell, basically what we are saying is that these cells, they are the electrochemical or galvanic cell. But when we are reversing the reactions, in this case, the galvanic cell that becomes equal to electrolytic cell. Why? Because we are going to provide electricity potential from external potential from outside. Therefore, while recharging such batteries, during recharging of the batteries, the galvanic cell is converted to electrolytic cell. The galvanic cell that is converted to electrolytic cells. The first very common type of battery which we are going to discuss over here, that is the lead storage battery. That is the lead storage battery. This is the battery which is used in cars. So this is also known as car batteries. Okay. Now this battery, it consists of a container, elongated container, in which we alternate lead and lead dioxide plates. So this is how we are placing we are placing one kind of plates and alternating them with other kind of plates. Okay, so when we're taking this, let's say that at the anode, this is the anode which we're taking over here. The anode that is made up of lead plates, and because it is an electrochemical cell, so the anode over here, it is going to have negative charge, okay? And the cathode is made up of lead dioxide plates. So cathode over here is positively charged and the anode that is negatively charged. So let's look at the reactions of both, but before that, the electrolyte which we take over here, so I am writing it over here, the anode is made up of lead plates, cathode is made up of lead dioxide, the electrolyte which we are taking over here, that is a solution of H2SO4, which is taken to be 30% solution of H2SO4, which behaves as an electrolyte. Now let's look at the reactions. Reaction at anode. Anode पे lead that is going to lose 2 electrons to give Pb2 positive. Okay? This Pb2 positive over here that reacts with the sulfate ions of the electrolyte to produce PbSO4. At cathode, the PbO2 lead dioxide reacts with the H positive ions. Okay. Now at cathode, reduction is going to take place. So we have to give us Pb2 positive, okay, plus 2H2O. Okay. Now again the Pb2 positive which is formed over here, that is going to react with SO4 2 negative to give PbSO4. Now let's write down the overall reaction of the cathode of the anode first. So anode ki overall reaction is going to be what? I am placing it over here only. I'll put it there. So we have Pb, overall reaction of this, Pb, this and this gets cancelled. ठीक है, -2 इलेक्ट्रॉन्स तो आएंगे, बट उससे पहले we have SO4 2 negative, -2 electrons to give us PbSO4. Similarly, let's talk of the overall reaction of the cathode. So overall reaction of the cathode, this gets cancelled with this. So we have PbO2 plus 4H positive plus 2 electrons, SO4 2 negative plus 2 electrons to give PbSO4 plus 2H2O. ठीक है? Now over here, let's now see the overall reaction of the entire cell. So we have, this is the overall reaction of the anode and this is the overall reaction of the cathode. So the overall reaction over here, that is going to be Pb plus SO4 2 negative. How many SO4 is going to be there? One SO4 is there and one SO4 is here. So we have Pb plus 2 SO4 2 negative plus PbO2 plus 4H positive to give us two PbSO4 plus 2H2O. Okay, so this is the overall reaction of the lead storage battery. Now in this case, if the reaction gets non-operational. How will the reaction get non-operational, or the cell will get non-operational? We can see over here that sulfuric acid is being constantly consumed. Okay, so it so happens that the density of sulfuric acid that may become less. When the density of sulfuric acid will become less, the reaction will stop, and as a result the cell is also going to stop. So for recharging the battery, what we are going to do now is, we are going to give it potential from outside in such a manner so that the reverse reaction of this can be followed. Okay? So for recharging of the battery, what is going to be the reaction then? During recharging of the battery, a reverse reaction will take place and the galvanic cell that is converted into electrolytic cell. So the reaction is OH positive plus PbO2. Okay, so this is the reaction which is going to take place during recharging of a lead storage battery. The second type of cells which we are going to discuss over here, that is the nickel cadmium storage cell. The second cell which we are discussing is nickel cadmium storage cell. Right? Now in the nickel cadmium storage cell, we say that this cell is more expensive than the lead storage battery, but it is light. Therefore it can be used in calculators. It is lighter than and also it is used in other portable tools, mechanical tools. In this cell, the anode that is formed of cadmium cathode is formed from hydrated nickel oxide. Right? And then electrolyte over here is aqueous solution of KOH. Aqueous solution of KOH. So let's go on to the reactions. And anode, cadmium reacts with OH from the electrolyte. To give cadmium hydroxide. At cathode, the nickel dioxide reacts with water to give us nickel hydroxide plus 2OH negative. Okay. Now in this case, when we are writing the overall reaction, again you can see that this is going to get cancelled with this, and both the electrons are also cancelled. So we have Cd, cadmium plus nickel dioxide plus water to give us cadmium hydroxide plus nickel hydroxide. So this is the overall reaction, and in this reaction also you can see that there are no ion formation taking place. So this also has a greater life. Is it clear? So this is the nickel cadmium storage cell. Then we come to a very special kind of cell, galvanic cell, which is known as the fuel cell. Fuel cell. Fuel cell is a very efficient kind of cell, and the fuel cell which we are going to discuss over here, that is the hydrogen oxygen fuel cell. Okay, now in this cell, in the fuel cell, we say that this is a constantly operational cell. Why? Because in this we are providing certain gases from outside whose supply cannot be cut down easily. Okay, so the efficiency of this cell is going to be larger than the other cells which we are using, and generally this kind of cell, it is used in spacecrafts. It is used in spacecrafts, right? So the fuel cell basically consists of a center compartment which has the electrolyte and porous electrodes on both the sides. Porous electrodes, and over here we are continuously supplying the two gases, these are the porous carbon electrodes, and over here we are taking the electrolyte which is KOH. Okay, let's say this is the anode. The anode over here, that is going to be negatively charged, and from the side of the anode we are supplying hydrogen. And this is the cathode which is positively charged, and we are continuously supplying oxygen. Okay, now because of this there is certain reaction which is taking place over here, and a lot of water gets accumulated. This water can be removed from this outlet. When we are talking of the fuel cell, the reaction at the anode, hydrogen reacts with the hydroxyl ions of to give us two electrons, and the reaction at the cathode, the oxygen over here reacts with water and to give us 4OH negative. Okay, so over here because we are making 4OH negative, so this side also 4 electron exchange is going to take place. To balance the number of electrons, we multiply the above equation by 2. Okay, so over here this and this, it gets cancelled out, and this 4OH and this also gets cancelled out. Over here it is 4H2O. So the overall reaction would be 2H2 plus O2 to give us 4 minus 2, 2H2. This is the overall reaction. Okay, so you can see that in the overall reaction water is being produced. That water, it can be taken out from the outlet which is present over here. Now as I just told you, these type of cells, these type of fuel cells, they have high efficiency because there is no dearth of gases which can be supplied continuously from the anode and the cathode. Okay? And secondly, they are pollution free, because what are we getting over here as a product? That is only water. So they do not pollute the atmosphere. When we are talking of the efficiency of this cell, the efficiency of fuel cell, that is denoted by eta, and mathematically eta, that is equal to delta G upon delta H. Okay? So this is what a fuel cell is. Then we have another kind of cells which are known as concentration cells, and this I am telling you because this will help you to calculate the E cell of certain questions which are given to you. So we have concentration cells. Concentration cells. What are concentration cells? Concentration cells means that if we are placing, say, plates of same metal, right? Like we have taken plates of zinc and we are placing plates of zinc in the same electrolyte, but with different or same concentrations. So in that case, we get two types of, you can say, expressions to calculate the E cell. The first one is electrode concentration cells. Electrode concentration cells. In case of electrode concentration cells, there is a net potential difference which is generated between the two electrodes at different concentrations, right? So a potential difference that is going to be generated or developed at two different concentrations. So if we are taking, say, any gas, we are let's take hydrogen as a gas. Okay, so in this case, when we are calculating E cell, that will be equal to 0.0591 upon N, or if you are taking hydrogen, the electron exchange, that is going to be equal to 2 log of, over here because we are taking a cell, we are going to consider the pressure, log of P1 upon P2. If we consider the concentrations, if concentrations are considered, then in that case E cell, that will become equal to 0.059 upon 2 log of C1 upon C2. Okay? The second type of cell we have is electrolytic concentration cells. We have electrolytic concentration cells. In case of electrolytic concentration cells, we have identical electrodes and they are immersed in solutions of same electrolyte of different concentrations, right? So let's take a cell which is, we are taking zinc as the anode. They are connected through a salt bridge and zinc only is taken as the cathode. Okay, let's say the concentration of the anode, that is C1, and the concentration of the cathode, that is C2. So what is going to be the E cell over here? 0.059 upon N log of C2 upon C1. Cathode upon anode. Otherwise, generally the electrochemical cell is given as what? Log of anode upon cathode. Right? E cell is given by that. But over here we are taking electrolytic concentrations. Therefore, you can see now it has become log of cathode upon anode. Right? So this basically the concentration cells, what are their applications? They are used to calculate the solubility of sparingly soluble salts right? And number two, they are also used in calculating the valency of cation. Right? Valency of cation can also be calculated, and it helps us to calculate the transition point of two allotropes. It helps us to calculate the transition point of two allotropes. Right? The two allotropic can be taken as what? One can be taken on the left hand side as a metal rod, and the next will be taken at the right hand side as a metal rod. So with this we finish this chapter. There are a few questions which I would discuss in the last class of this tomorrow. Okay? And we start with the fourth chapter, that is kinetics.